Hi viewers, this is Sri Ramlu. So today's topic is magnetic field induction due to a solenoid or solenoidal field. And here the magnetic field induction is derived by using Biot Savart law only, not by Ampere's law. So it is by using Biot Savart law. Okay, so see. A long, tightly wound helical coil of wire is called as solenoid. Solenoid definition, this is C. A long, tightly wound helical. Helical means like this. If you wound wire like a spring, that is called helical. Helical coil of a wire is called solenoid. See here, the solenoid is also wounded like this. So inside it is what you know. So this is the pipe, or it is a bad conductor. On it wire is wounded like this, okay, like a spring. So that is called solenoid. Consider a coil is wound as spiral on a cylinder of non-magnetic material. Here it is a non-magnetic material. On it one wire is wounded. The length of the solenoid is far greater than its diameter. Okay, so far greater than its diameter. Suppose diameter is, see here, it is, so this is a length, let it is a length L, or it is a 10 meter, and its diameter may be, let it is a 2 centimeter, or it is a 10 centimeter, 2 is it. So length must be greater than its diameter. Let capital N be the total number of turns in the solenoid. So from this end to this end, how many windings are there? Those total windings are denoted by a letter capital N. Okay. The number of turns N per unit per meter will be N by L. Suppose, see, it is a total number, and from here to here length is L. So this is taken as N. Okay, small n. This small n is called number of turns per meter. Number of turns per meter. Number of turns per meter is N is equals to total number of turns by length of the solenoid. Okay, suppose the solenoid carries a current I ampere. See, through it current is flowing. Okay, I amount of current. Here in 3 different cases you have to calculate the magnetic field B. 3 different cases. First case, what is? Field at inside of the point. Right? Inside of the point means inside the solenoid. Inside of the point means inside the solenoid. Here we shall calculate the magnetic induction B at a point P inside the solenoid on the axis. Okay, inside the solenoid, but on the axis we have to calculate. For this purpose we divide the solenoid into number of narrow equidistant coil. For this purpose what we have to do, we have to divide this into narrow means very small pieces, small equidistant pieces. Now consider one such a coil of width dx, there will be n dx turns. So such a coil is taken here, see here. Now first let me divide it, I will explain. See here, let it is a complete solenoid. For this what we have divided into small pieces, right? Small pieces. Among them one such a piece is taken outside. See that that piece is what? This is a piece. So this is divided, this is the piece. Alright, so this piece is taken outside. Okay, so like this, just now I have shown you like a parallel line. So once again see here, here also given. Okay, see, it is a solenoid. Okay, so inner part is showing, and it is axis which is passing through the center of the solenoid, and here many pieces are divided. Among them one piece is taken here, one piece at what a distance, let one point is P on the axis, and so this piece at a distance x. Okay, and let it is making angle theta, and here the two ends are there. So here to here one end and it is end. So P to B1 and P to A end. So in between them P to B and P to A. So small gap will be there. So that small gap makes an angle d theta, small angle. And at what a distance they are? See, at what a distance? They are at a distance small r. And let its diameter is how much? A. Right? Sorry, it is radius, not diameter. Let A be the radius of the solenoid. And see, it is dx is a small piece. Okay, so small piece. So many pieces are divided, among them it is one small piece. See, it is a total length. Okay, so keep in mind this picture. Again I will show you. Okay, let x be the distance of point P from center O of the coil. See, here to here distance, it is what? It is x. The field at point P due to the elementary means very small, elementary coil of width dx carrying a current I is given by. So through it already I have shown you above, the current is flowing, that is I amount of current is flowing, I have shown. So we can we know that magnetic field due to a circular coil at a distance x from its center. So it is not no videos is done on it, but please listen. So like a circular coil is taken, that is already we have in textbooks. Let it is a point P and a current is flowing through this circular coil is I, it is center, and let point P is at a distance x from the center. Okay, then when the current is passing through the circular coil, single it is circular single coil, then around it what happens? Magnetic field will form. That magnetic field also present at this point. Then at this point how much present? So let this point is at what distance? At a x distance. So for this derivation is there, but no need to derive here, but you must keep in mind only one formula, that is what you know. So that is this one only, that is the dB. It is derived with help of the Biot Savart law only, not with Ampere's law. Biot Savart law, don't forget it. Okay, what is that? dB is equals to mu naught n I a square by 2 into a square plus x square power 3 by 2, where here a is what? A is radius. Okay, x is the distance from the center to point P, and a capital N is what? Number of turns in the solenoid. Okay, so a is okay over all over, mu naught is we know that is a constant. And what I am doing, I am going to change this formula as, just now I explained you small n is what? Total number of turns by length, right? Here which length? Here length is very small, dx length is taken. Instead of L, small length is taken, dx. So see, number of turns by length, dx is the small length. For that is for considered area, for considered what we call considered length only, in considered length only. So from this capital N can be written as capital N is equals to n dx. So in the place of capital N dx is written. From figure, considering the triangle ABC, so this diagram, whatever diagram is taken here, see here, whatever piece is taken, dx piece is taken, so this is only this is taken outside in enlarged form, means in big in size form. See, in the below is given, it is okay. Once again see them, sorry, here A point, B point, A, B. Okay, similarly O, here O, only upper part is taken, not a lower part. And is a x distance, point P, dx, d theta, theta, r, everything is there. So it is enlarged form, right? Enlarged of this diagram. Enlarged V we call generally. Enlarged view. Okay. So which triangle we have to consider here? The triangle ABC triangle. A B ABC triangle, sorry, A B C triangle. So 90 degrees present at C only, right? At 90 degrees at C. But see, it is a theta, then it is also theta. Why? Because this line and this line are parallel, and this point is, this line is starting from this point and ending and touching to that parallel line only. So that is why both like parallel, then this angle also same. And here to here distance is what? It is a small r. Then we know that what let AB is arc, right? Arc can be written as what? Arc is equals to angle into what? Radius. Arc is equals to angle into radius. Here the angle is C, AB having the angle d theta, so d theta, and here to here distance radius is what? R. So that is why r theta is written here, right? What is arc? AB is the arc. Okay, AB is the arc, right? So here it is 90 degree. Here to here distance is what? Small r. Then this is what? This, if you take AC, not AB, AB already we know, AB value is dx. Okay, so AC value we don't know. AC is what? AC is equals to angle into radius. Angle into radius means it is AC is, if you take it as arc is equals to angle into radius. Okay, now so AC value we know, r d theta, right? Now apply the sin theta, right? Apply the sin theta to the triangle ABC only, to the triangle ABC only. Okay, apply the sin theta, sorry, this is how we get, consider this triangle. Okay, AC, it is angle what? D theta angle. Okay, then it is R. Arc, it is arc generally. Arc is equals to radius into angle. So that is why it is r d theta. So r of arc is shown, see, r d theta. Okay, so it is r d theta. Now apply the sin theta. Sin theta for what things we have to apply? We have to apply the sin theta to the only ABC. A, B is C. So this right angle triangle, right, where the 90 degrees present at C. So that means AB is what? Simply it is a hypotenuse. Why? Because 90 opposite side is hypotenuse, right? So sin theta is equals to opposite by hypotenuse. Opposite is r d theta. Hypotenuse is AB. AB is what? It is a length dx, right? See here in the diagram, AB is what? Dx only. So that is why here sin theta is equals to r d theta by dx. From this dx is equals to, we can write sin theta, r d theta by sin theta. Okay, next from figure, keep it like this only. Why? Because here we have to substitute, that is. Next, from triangle APO, from triangle APO, APO, this triangle. So 90 degree present at where? At O only. See, it is exactly vertical line, O. So that means it is hypotenuse, right? Hypotenuse is R. Okay, now see here, hypotenuse is R. We know that according to Pythagoras, what formula? Hypotenuse square. Hypotenuse is what? Here hypotenuse is R. R square is equals to side square plus side square. But this is what? It is A. See here, that is what? A. So this is A. So R square is equals to A square plus X square. So same thing is written here. So from this R square, so we can write from this, we can write like this only. This is how we know, how we get this one. See what we got, R square is equals to a square plus x square. Bring this square that side, then r is equals to a square plus x square power 1 by 2. Cube on both sides, it is cube, it is also cube. So a square plus x square power 3 by 2. A square plus x square by x square power 3 by 2 is equals to r cube, like this. Let's see enlarged view it is. Okay. And next, substituting above values in the equation 1. Which values we have to substitute? Dx value and r cube value. Okay, dx value and r cube value. See. So in the place of this, what we can substitute? We can substitute r cube. In the place of dx, we have to substitute this one. See here. So in the place of dx is substituted what? That is r d theta by sin theta, and in the place of a square plus x square power 3 by 2 is r cube is substituted, that is denominator. So from this r is there and s cube is there, it becomes not cancelled now. And see here, let me separate it like this. Okay, so it is sin theta is written in denominator. Now cancel it. R cube, it becomes square. Okay, and the remaining things are same. Next, from figure, see here what we can write. It is square and it is square, so write them separately. Okay, from figure, sin theta is what? A by r. How we get sin theta a by r? See the diagram. So a by r, see here. Take now this right angle triangle. Okay, or this right angle triangle also we can take this right angle triangle. So it is a means, then this is also a. Apply the sin theta. So sin theta, what? It is the angle here, opposite side is a, by sin theta is equals to a by hypotenuse is r. So sin theta is equals to what? Simply a by r. Sin theta is a by r. See, sin theta is a by r. So in the place of a by r, sin theta is substituted, but square is there, so that is why square is written. So for square, sin theta cancelled, one sin theta will be there. Now remaining quantities are like this. Okay, now integrating on both sides. Integrating equivalent equation to integrating equation 2 between theta 1 and theta 2 to get total magnetic field is. So integration here, differentiation cancel, only b will remains, and this side is theta 1 to theta 2. And the take outside the remaining constant quantities mu naught n I by 2. All inside sin theta will be there. So we know the sin theta integration is minus cos theta. Limits where to where? From theta 1 to theta 2. And apply this one, then we can get. If you apply, if you write these limits inside, what we get? We get b is equals to mu naught ni by 2 cos theta 1 minus cos theta 2. So this is the equation of solenoid magnetic field due to the solenoid by using what? Which law? By using Biot Savart law. Next, let me go inside. Let me apply. This is to the inside. It is a solenoid. It is axis. Okay, inside. Inside means take at any axial point P, when it is well inside very long solenoid, theta 1 is 0, theta 2 is okay. Let it is take here, it is very long means up to infinity. This end is up to infinity, this end is also up to infinity. Then here, so take this value at this end and this line at this end. This angle is generally theta 1 we take, and this angle is theta 2. Theta 1 and theta 2 are taken from the right side only. Okay, so it is a theta 2 total angle. This is a small angle is theta 1. Okay, when it is at infinity, what happens? You know, now it is here, line is coming here, now it is here, then line C like this. Again, if you take, line can pass through the What? Through the axis only. Through the axis means angle cannot present, so theta 1 value is 0. Now see here, theta 2. So when the end is here, then angle is this much. When end is here, now see angle increasing, angle theta 2 angle increasing. When end is at infinity, then this line may pass along the axis, Now if you take the angle, we have to take angle like this, anti-clockwise. So then it gives how much angle? 180 degree it gives. So that is why theta 2 is taken as 180 degree, that is pi only. Okay, so if you substitute these values in the above equation, okay, it is theta 1, it is theta 2. Theta 1 value is 0, theta 2 value is pi, cos 0 is 1, and cos pi is minus 1. Already minus is there, minus become plus, so 1 plus 1 2 gets cancelled. What we get? We get this one. So B is equals to mu naught Ni is the magnetic field due to a solenoid. Inside it, when the solenoid is very long means at infinity, up to at infinity. Second case, what is the second case? See, second case is what? Field at an axial point. Field where? At end point. Now it is not in the middle. Take at any one of the end. So for this, what I am doing, I am going to take at a left end only. So let it is a left hand, it is right hand, but right hand at infinity. Okay, left hand is here, right hand at infinity. Let it is axis. Let take it is point at this end. Okay, and here it is one line, and it is theta 1. Theta 1 is always with the right hand only. So right hand where it is at infinity. So then theta 1 value is 0. And left hand, see, second hand, left hand is see at this point only, left hand. And how we have to take a theta 2? Like this, clockwise, anti-clockwise direction, theta 2. So it is theta 2 is simply, we can say it is 90 degree. Theta 2 is 90, theta 1 is 0, theta 1 0, theta 2 90. Substitute. Then what do you get? Cos 0 is 1, cos 90 is 0. See, we get this is. If we compare these two equations, where the maximum field present, it is a maximum field, it is half of this value, right? Half of this value. Next, third case is what? Let me explain. Find a field at a center of a solenoid of finite length. So up to second case we have taken infinite length. Long, I said you long. Long means up to infinite. But in third case we have to apply to the finite length only. Finite length means let L length. It is a solenoid. Let its length is L. Okay. Let me take here one point exactly in the middle. Okay, exactly in the middle. Point P. Okay, this point lies from this end L by 2 distance. This point also lies from right end L by 2 distance. Okay, it is L by 2 distance, from this side L by 2 distance. Okay, so point P, and I take this angle, it is a theta 1, right side angle theta 1. This side, take this angle, it is a theta 2. Okay, so theta 1 is right side, theta 2 is left side. Keep in mind. Okay, so let me erase this diagram once again. Right? What is this? Solenoid of finite length. Point is in the middle. At what distance? L by 2 distance from left end, L by 2 distance from right end. Point P. This end is theta 1 and this side is theta 2 angle. Okay. Right, so here to here distance what? It is a diameter, radius. Radius is taken as A. Okay, and this side also, this end, this from axis to this end is what? It is also distance A. Now consider this. See, it is one right angle triangle. It is forming one right angle triangle. This is also forming right angle triangle. Okay, so this is angle, right side angle is theta 1 and this angle is theta 2, but we don't know this angle. How can we calculate that angle? See, I will tell you. Point P, L by 2 distance from left side, L by 2 distance from right side. It is A, it is also A. Draw one line. It is angle is theta 1, and left hand, this angle is theta 2. So this angle is theta 2, but from here to here total angle is 180. So you know this angle, you don't know this angle. This angle can be calculated subtracting from 180 to this theta 2, then we get this one, right? Isn't it? So up to here it is theta 2. It is what? Pi minus theta 2. So this angle is what? Pi minus theta 2, right? So that is why see here, pi minus theta 2. Pi minus theta 2 is subtracted. Cos theta 1, how we got? Once again see the diagram. I think diagrams also there. Okay. Yes. Diagrams also there. So it is a previous diagram. When at one end, when we keep here like this angle is 90 and this side angle is 0. So it is for this diagram, and for this diagram see, for third point is diagram see. It is a finite length, right? So it is, if it is total length, then it is half. It is also half. This angle is theta 1, this angle is theta 2, then this angle is pi minus theta 2. This side is A, this side is also A. First take this one and apply cos theta 1. Cos theta 1. Why? Because this side angle is theta 1. Cos theta is what? We know, at adjacent by hypotenuse. Adjacent is what? It is adjacent L by 2. L by 2 by hypotenuse. Hypotenuse, this is we don't know, but we know it is L by 2, it is A. According to Pythagoras, what? Hypotenuse square is equals to side square plus side square. Hypotenuse square is equals to, let hypotenuse as R square is equals to side square, L by 2 whole square. It is A. What is this? L by 2 whole square plus A square is equals to hypotenuse square. Hypotenuse square, let it is H square. Bring this square this side, it becomes under root R power 1 by 2. Okay, power 1 by 2. See here, same thing. L by 2, cos theta is equals to adjacent. Adjacent is L by 2 by hypotenuse. Hypotenuse is A square plus L square by 2, L by 2 whole square power 1 by 2. Okay, so again this is written as like this. Okay, so clearly see the diagram with, along with the diagram, right? From this diagram only we can get this one, and from this side we get this one. Why it is cos pi minus theta? This angle, only this angle. Cos pi minus theta, we know the cos 180 minus theta is minus cos theta. So that is why here minus is attached. See here, minus is attached. At this point, minus is attached. And what we got here, the same we will get here. Same thing, but with minus. Opposite value we will get. Why? Because this is A, this is L by 2, it is A, it is L by 2, then whatever we get this side, the same value we get this side, but opposite. So it is opposite means minus. Okay, and take these two values, cos theta 1, right, and cos theta 2. Cos pi minus theta 2 is minus cos theta. This minus taken this side, so cos theta 2 is minus L by 4A square plus L square power 1 by 2 is written. Okay, substitute them in the equation 1, or sorry, equation 3. So what is equation 3? This is a previously we have derived. Okay, see at the above we have that diagram, that equation. See third equation, this is a third equation. So cos theta 1 we got, cos theta 2 we got, but cos theta is minus we got, so minus minus become plus, so that is also written. See here, cos theta 1, this is cos theta 2, this is but minus, this minus minus plus, so plus, but this is, these two are same, then it is 2 into added, how many are there, 2 are there, so 2 into, so these two gets cancelled, this is the final answer. Okay, see here small n is there, small n is replaced, small n is what, capital N, capital N by L we get, right, or NL is equals to capital N is written, so this is the final answer. Okay, so this is a magnetic field due to a finite length of solenoid, already infinite length for infinite we got. So okay friends, so this is a very very important, it is by using what, it is by using Biot Savart law only, solenoidal field. So again we have the magnetic field induction due to solenoid, but by using Ampere's law we have, so it is by using Biot and Savart law. So again I will explain with help of Ampere's law, that is a very short but it is a longer one. Okay friends, thank you.